In this video, I'm going to show you how the electric bike system works using my Trek electric bike. It covers the following sections: parts and connections, system block diagram, I2C bus, power delivery diagram, control loop, I2C registers for motor and battery, battery connector pin out, and references. The Bion-X electric bike system has three main parts: controller, motor, and battery. Also, it has e-brake sensor and lights. Console has a cable connected to the battery. The e-brake directly connects to the console. There are two cables between the battery and the motor. A small cable connects the headlight and the battery. I2C bus is used to communicate between controller and other parts. Some Bion-X system using CAN bus, which is out of scope of this video. I will show you how to identify the I2C or CAN bus system at the end of this video. From the I2C bus perspective, there are four nodes. MCU is the master node. LCD, motor, and battery are the three slave nodes. Let's have a quick look of the I2C bus. I2C bus includes one or more master nodes and one or more slave nodes. Each slave node has a unique address. Master node sends a request to the specific slave node. All the slave nodes receive the request, but only the slave node match the address responses. There are two pull-up resistors on the two bus lines, so the bus measures high when idle. This is a more detailed system diagram. It shows the e-brake keypad, battery status including voltage, temperature, and capacitance, motor status including speed, load, torque sensor, and power output. The system diagram looks complex, but the main work cycle of the control system can be simplified down to two steps. First, MCU continuously inquires torque sensor. This is an example of the torque sensor from other e-bike motor. Then, MCU controls the power output via the MOSFET. That is the simplified two-step main control loop. In reality, the control loop is more complex, because the MCU needs to consider other inputs, such as user setting, e-brake sensor, motor revolution, motor load, battery voltage, battery temperature, battery remaining capacitance. When the power is switched on, MCU inquiry and initials the LCD, motor, and the battery via the I2C bus. Then MCU checks the torque sensor and other inputs, such as user setting, wheel speed, e-brake sensor, etc. Then the MCU sets the motor output power. Also, LCD shows the real-time data such as power output, battery voltage, speed, etc. In addition, the MCU will monitor the system health status such as motor temperature, battery voltage, etc. The control loop keeps running until powered off. This is the power delivery system diagram. The battery of this bike is 4P11S with rated voltage of 40.7 volt. Each group has 4 18650 batteries connected in parallel. Then 11 groups are connected in series to provide the required voltage. Details of the battery pack can be found in my other video. The battery pack provides 240 volt to the motor, 140 volt via the thick motor power cable, another 40 volt through the small control cable. Please note, for Bion-X CAN bus system, the voltage on the motor control cable is 12 volt. The battery pack also provides 5 volt to the controller and provides 6 volt to the headlight. This is the DB7 pin out for the Bion-X battery connector. These are the I2C registers for the motor. These are the I2C registers for the battery pack. Those registers are worked out by others via reverse engineering. You are welcome to provide more details. The first 4 digits of the Bion-X serial number is the part number. This lookup table maps the Bion-X part number to the system bus type, so you can find out if a part is using the I2C bus or CAN bus. Here is a list of useful references. Please leave comments below if you have any questions. I hope this video is useful to you. Please like, subscribe, and share to support me. Thank you.